Hi all, welcome back to Arise online classes. So today we are going to discuss about structure of atom. I hope all of you will be familiar with atomic structure. So let's move on to the topic, okay? Yeah. So as you know, in the earlier stages, like in the Dalton's atomic theory, it was assumed that atoms are indivisible, right? Atoms cannot be divided into so small subatomic particles. That was the concept during Dalton's atomic theory. But later on, after the discharge tube experiment, it was found out that there are some subatomic particles like electrons, protons, neutrons. All these are subatomic particles. And you know now, electrons are negatively charged particles, protons are positively charged particles, and poor neutrons are chargeless species. They are neutral particles. So here in this chapter, in the structure of atom chapter, we are going to discuss or start with the subatomic particles. Okay, so let's start with electrons. As you know, electrons are negatively charged particles, and they are also known as cathode rays, because during the discharge tube experiment, these particles are found to move from cathode and towards anode. So that's why they got the name cathode rays. They are moving from cathode towards anode, because they are negatively charged particles. Obviously they should move from cathode towards anode. And what about the charge of electrons? You know, they are negatively charged particles, and the charge of electron is exactly, it is minus 1.6 into 10 raised to minus 19 coulombs. You have to by heart all these values: charge of electrons, mass of electron, then again charge and mass of protons. All these things should be there in your mind, okay? Yeah. So starting with the charge of electron, that is minus 1.6 into 10 raised to minus 19 coulombs. And what about the mass of electron then? Mass is equal to 9.1 into 10 raised to minus 31 kilogram. That is a mass of electron. I am saying the values in kilograms. So it is 9.1 into 10 raised to minus 31 kilogram. Then you have to by heart one more value. In the case of electrons, the charge to mass ratio, E by M ratio, that is charge to mass ratio. And for electron, the value is 1.6 into 10 raised to 11 coulombs per kilogram. Okay. So in the case of electrons, you have to study all these simple points, like you know, electrons are negatively charged particles and the charge is equal to minus 1.6 into 10 raised to minus 19 coulombs, whereas the mass of electron is 9.1 into 10 raised to minus 31 kilogram, and charge to mass ratio is nothing but 1.76 into 10 raised to 11 coulombs per kilogram. And you know, they are starting from cathode in a discharge tube experiment. What do you mean by discharge tube experiment? You will take a evacuated discharge tube and you will experiment with different gases. You have to fill the discharge tube with different gases, and you will study the nature of these particles, right? And it was found that there was a set of radiations starting from cathode moving towards anode, and that was electrons actually, right? And the nature of these cathode rays does not depend upon the nature of the gas taken in the discharge tube, correct? The nature of cathode rays does not depend upon the nature of the gas taken in the discharge tube. And as you know, as these are charged particles, they will be deflected by electric and magnetic fields, correct? The cathode rays are deflected by electric and magnetic fields. And when they fall on fluorescent or phosphorescent substances, they will produce a glow. So all these are properties of cathode rays or electrons. Okay, you have to by heart the values definitely, and these simple points also about cathode rays. Fine? Yeah. Now moving to the next subatomic particle, that is protons. Do you know what is another name for protons? Yeah. If electrons are known as cathode rays, definitely protons are known as anode rays. And from the name itself, you will get an idea that they are moving from anode towards cathode. During the discharge tube experiment, it was observed that a set of radiations are starting from anode and they move towards cathode, and these particles are found to be protons, right? And another name for proton is canal rays. They are also known as canal rays. Okay, yeah. And as you know, protons are positively charged particles. What about the charge of proton? Proton will have exactly the same charge as that of electrons, but just opposite in sign. These are positively charged particles and the charge is 1.6 into 10 raised to minus 19 coulombs. And about the mass of proton is equal to 1.6726 into 10 raised to minus 27 kilogram. Okay, you have to by heart the values definitely. Charge is nothing but just opposite as that of electrons, and mass of proton is equal to 1.6726 into 10 raised to minus 27 kilogram. Okay, and definitely these are also charged particles, so they got deflected by electric and magnetic fields, correct? And the nature of these anode rays or protons depends upon the nature of the gas taken in the discharge tube. That was a difference with respect to the property of electron. The nature of protons or the nature of anode rays depends upon the nature of the gas taken in the discharge tube. Clear? Yeah, so electrons are negatively charged subatomic particles, whereas protons are the positively charged subatomic particles. Shall we move to the third one? What was the third subatomic particle? It was neutrons, correct? But the poor neutrons with no charge actually. Neutral particles present in atoms are neutrons. They are neutral, so nothing to worry about the charge, but you have to by heart the mass of neutron, and that is equal to 1.67493 into 10 raised to minus 27 kilogram. At least you by heart 1.675. Okay, yeah, so the exact value is 1.67493 into 10 raised to minus 27 kilogram. That is a mass of neutrons. Fine? Yeah. So these were some brief description about the subatomic particles, but this chapter is mainly dealing with atomic models, correct? Yeah. So let's move on to the next main topic, that is the different atomic models. Yeah. Here comes the first atomic model, the first prominent atomic model, that is proposed by J.J. Thomson. And the model is known as J.J. Thomson's plum pudding model. Actually my favorite one. I am a foodie person, so plum pudding model is very favorite for me. So what do you mean by plum pudding model? According to this model, atom consists of a positive sphere where the negatively charged electrons will be scattered here and there, just like plums in a pudding. You know, in a pudding you will decorate it with plums. So just like that, atom is a positive sphere with the negatively charged electrons scattered here and there. This was a simple concept behind the J.J. Thomson's plum pudding model. Okay, it was an interesting model when you heard it for the first time, but when we moved to the details of that model, that was not appropriate, right? Yes. So after that J.J. Thomson's plum pudding model, the next prominent atomic model was Rutherford's atomic model. But before going to the atomic model concept of Rutherford, we have to discuss something about his experiment part, the alpha particle scattering experiment, or you know, it is also known as gold foil experiment. And we have to go through the observations of his experiment, then with the conclusions, and after that we will conclude with the atomic model, Rutherford's atomic model. Fine. So shall we jump to the next one, that is Rutherford's atomic model. Rutherford's atomic model. Yeah. So I will start with the experiment part. As you know, his experiment is the famous experiment known as alpha particle scattering experiment or gold foil experiment. Alpha particle scattering experiment. So he was doing experiments with alpha particles. So alpha particle scattering experiment or gold foil. Gold foil experiment. So what was the experiment actually? He took a source which can emit alpha particle. Okay, a source was taken which can emit alpha particle, and these particles were allowed to fall through or pass through a gold foil. Okay. These alpha particles were passed through the gold foil, and the emerging radiations were allowed to fall on a photographic film so that he could study more about the emerging radiations. And what he find out that, so this was the experimental part, a very simple concept. He took alpha particle which can emit he took a source which can emit alpha particle, and you know alpha particles are similar to helium nucleus, correct? This is helium nucleus with atomic number 2 and atomic mass 4. So he took a source which can emit alpha particle, and these alpha particles were allowed to pass through a gold foil, a thin film of gold, that is gold foil, and the emerging radiations were studied. And what were the observations of this experiment? What did he observe? The observations were, most of the alpha particles passed through the foil without any deflection. Okay, that was the first observation. Most of the alpha particles passed through the foil without any kind of deflection. And the second observation was, some of the alpha particles got deflected. Okay, so somewhat having some problem with that. So some of the alpha particles got deflected, and a very few alpha particles, at about 20,000 particles, at least one of them was deflected at an angle of 180-degree deflection. What do you mean by 180-degree deflection? If a particle is coming like this and if it got deflected in the same axis, that will say like this. If the alpha particle is coming in this direction and if it got deflected exactly in the same axis, you will say 180-degree deflection, correct? So a very few alpha particles were deflected at an angle of 180 degrees. So these were the observations of his experiment. Most of the alpha particles passed through the foil without any kind of deflection. Some of them were deflected, and a very few, that is out of 20,000 particles, only one was deflected at an angle of 180 degree. Okay. So these were the observations of Rutherford's atomic model. And from these observations, he concluded his atomic model. What were the conclusions of Rutherford's atomic model? Do you know what are the conclusions? The first point is, since most of the alpha particles are passing through the foil without any kind of deflection, it indicates that atoms have vacant spaces. That was his first conclusion. Most of the alpha particles were passing through the foil without any kind of deflection. So that indicates that atoms have enough vacant spaces. That was the first conclusion. The first conclusion was that atoms have enough vacant spaces. Okay? Yeah, that was the first conclusion. Then second conclusion was that since some of the particles got deflected, there should be some positive charge present inside the atom. Why he is saying like that? There should be some positive charge, because you know alpha particles are similar to helium nucleus, and nucleus is behaving like a positive sphere because inside the nucleus you have positively charged protons and chargeless neutrons. So nucleus will behave like a positive sphere. So as the helium nucleus or the alpha particles are deflected, they should be striking with some positive charge present inside the atom, correct? Then only they will be getting deflected. So from his observation that some of the alpha particles were deflected, he concluded that there are some positive charges present inside the atom. That was his second conclusion. There are positive charges inside atom. Okay? Yeah, that was his second conclusion. Then what was his third observation? Yes, very few alpha particles were deflected at an angle of 180 degree, correct? So that means the positive charge inside the atom will be located at a particular point, and only those particles which are exactly striking this positive sphere will be deflected at an angle of 180 degree. Correct? So these positive charges inside the atom will be located in a portion at the center, and only those particles which are exactly striking this positive sphere will be deflected at an angle of 180 degrees. So his third conclusion was that these positive charges are located at a center, and he named that center as nucleus. Okay? So he ended up with the nucleus concept, this positive center present in the atom is nucleus. Okay. So, these were the conclusions of Rutherford's atomic model. Atom have enough vacant spaces, then atom consists of positive charges, and these positive charges are located at the center of the atom, and he named that center as nucleus. And if the radius of atom is in the range, if the radius of atom is in the range 10 raised to minus 10 meter, then the radius of nucleus will be in the range 10 raised to minus 15 meter. Okay, so that much small will be the nucleus, and this positive center is known as the nucleus. And by that time electrons were already discovered, so he also included the point that the negatively charged electrons are revolving around the nucleus in circular paths. Okay, so his atomic model include all these points, that atom consists of enough vacant spaces, and there will be some positive charges present inside the atom, and these positive charges are located at the center of atom, and the center is known as nucleus. Okay, and he also added that if the radius of atom is in the range 10 raised to minus 10 meter, then the radius of nucleus will be in the range 10 raised to minus 15 meter. And the next point was about electrons. The negatively charged electrons will be revolving around the nucleus in circular paths. Okay, yeah. So all these were the observations, or all these were the postulates of Rutherford's atomic model. So when you hear about this atomic model in the first glance, okay, this was a well and good explanation about the structure of atom, but it has got some limitations. So let's move on to the limitations of Rutherford's atomic model. What are compared to J.J. Thomson's plum pudding model, this was a well and good explanation about the structure of atom, but there were some limitations. So shall we move to the limitations of Rutherford's atomic model? Yeah, so let's see what are the limitations of Rutherford's atomic model. Fine? Yeah. So starting with the first one, the first limitation was the main drawback is actually this model was unable to explain the stability of an atom. Why? Why it was unable to explain the stability of an atom? Because according to his model, the negatively charged electrons are revolving around the nucleus in circular paths. And according to classical model of electromagnetic theory, when a charged particle is revolving around a nucleus, they will be continuously emitting radiations, or they will be continuously emitting energy in the form of radiations. So when they continuously emit energy, ultimately they will lose all its energy and they will fall into the nucleus. Correct? Then the atom will be unstable. So according to his theory, atom should be unstable ultimately, but actually atom is stable. So he was unable to explain the stability of atom. That was a main drawback of Rutherford's atomic model, because according to his theory, electrons are continuously emitting energy when they are revolving around the nucleus, and ultimately they will lose all its energy and they might collide into the nucleus. So he couldn't explain the stability of atom. Okay, so that was the first drawback. He couldn't explain the stability of atom. Okay, stability of atom. Yeah. And the second drawback was he couldn't explain the formation of spectrum. Have you heard about spectrum? What was spectrum? Spectrum is nothing but an arrangement of radiations in the order of their wavelength or frequency, correct? When you have to arrange some books or something like that, you can have different options, like some persons will be arranging them according to the topic, some will be arranging them according to the size, so different options are there. So when you are arranging some radiations, most probably you will arrange it in the order of frequency or wavelength. Correct? You have different electromagnetic radiations like microwaves is there, ultraviolet radiations, radio waves, X-rays, gamma rays, so many kind of electromagnetic radiations are there. So spectrum is actually a set of radiation arranged in the order of their wavelength or frequency. Okay? And an atom will produce spectrum. There will be some line spectrums or continuous spectrum obtained from each of the atoms. So Rutherford's model was unable to explain spectrum formation of an atom, why an atom is forming spectrum. So that he couldn't explain. So that was his second drawback of this model, that it couldn't explain the spectrum formation of atom. Okay, so it couldn't explain, again the second drawback is about the spectrum formation, couldn't explain the spectrum formation from atom. Okay, yeah. So that was the second drawback. So first drawback was about the stability of atom. He couldn't explain the stability of atom. Whereas the second drawback is about the spectrum formation. He was unable to explain why an atom is forming spectrum. Okay. And the third drawback was there was no mentioning about the electronic structure of atom in Rutherford's atomic model. He was unable to, or there was no mentioning actually about the electronic structure of atom. So that was the third limitation or third drawback of Rutherford's atom model. No mentioning about the electronic structure. Okay, yeah. So these are some limitations of Rutherford's atomic model. So in this section we have discussed about the subatomic particles like electrons, protons and neutrons, and we know these subatomic particles were discovered with the help of discharge tube experiment, and we know electrons are negatively charged particles with a charge minus 1.6 into 10 raised to minus 19 coulombs, and actually protons are positively charged with exactly the same charge but opposite in sign as that compared to electrons. And we have discussed through the mass of protons, mass of neutrons, which are the neutral particles present in an atom. And we also discussed about the E by M ratio of electron. What was the E by M ratio of electron? Yeah, 1.76 into 10 raised to 11 coulombs per kilogram. That was the E by M ratio of electrons. So you have to by heart all these values. Okay, yeah. And after that we have gone through structure of atom, or the different models, atomic models, starting with J.J. Thomson's Plum pudding model, which was a very brief description about atom. Like atom consists of a positive sphere where the negatively charged electrons are scattered here and there, just like electrons or just like plums in a pudding. Correct? And after that we have discussed about Rutherford's experiment, alpha particle experiment or gold foil experiment. We have gone through different observations of this experiment, and after that the conclusions or Rutherford's atomic model, that atom consists of different vacant spaces are there and a positive sphere present at the center of the atom is known as nucleus, and the negatively charged electrons will be revolving around the nucleus in fixed path. Sorry, the fixed path concept was about Bohr model. So according to Rutherford model, the electrons will be revolving around the nucleus in circular path. Okay, and they will be continuously emitting radiation when they are rotating. So ultimately they may fall into the nucleus, and that's why we say he couldn't explain the stability of atom. Fine. And the second drawback was about the spectrum formation of atom. He was unable to explain why an atom is producing spectrum. Okay, and what was spectrum? A set of radiations arranged in the order of their wavelength or frequency. Actually, we have to study more about hydrogen spectrum in detail in the same chapter itself. So these were the main points about Rutherford's atomic model. So as we said, there are some limitations for this model. So there will be another model which will overcome these limitations, and that was Bohr atomic model. Actually, this Bohr atomic model was somewhat similar to Rutherford's model, except some small changes. So about Bohr atomic model we will discuss in the next class. Okay, so wait for that. Thank you.